Solving radical equations, part 2 with extraneous solutions. Remember that extraneous solutions are answers when we mathematically solve something, but it doesn't make sense in the problem. And I'll show you a couple of those examples today. Let's go ahead and take a look at our first example. So our first example is the square root of x equals 2x minus 6. We are going to isolate the radical, it's already by itself, and we're going to clear the radical, which means we are going to raise it to the power of the root. This is a square root, so we're going to raise both sides of the equation to the second power. So what we're going to have is x equals 2x minus 6 squared. We're going to FOIL this out. When you FOIL this out, it is 4x squared minus 24x, and then the last part is going to be a positive 36. So we are going to solve a quadratic equation. In order to solve a quadratic equation, remember you have to set it equal to 0. So we're going to move that x over to the other side. 0 equals 4x squared minus 25x plus 36. 4 times 36 is indeed 144. So that's going to go at the bottom. So I really want numbers that multiply to make that and then combine to make that. I'm going to move this out of the way. So 144 are going to have a lot of factors, but the factors that we need are going to be 9 and 16. So 9 times 16 makes 144, and when you combine those two numbers, they make a 25. I'm going to make both of these numbers negative, and now I get to factor this quadratic equation. So 0 equals 4x squared minus 9x minus 16x plus 36. Out of this first pair of numbers right here, the only thing I can take out is an x. The second pair of numbers, I can take out a 4. I'm going to take out a negative 4 so that my signs match. Awesome. Factor by grouping. I know I'm on the right track because I have a matching factor. So 0 equals x minus 4, and then 4x minus 9. Let's go ahead and solve by the zero product rule. So x is going to equal a positive 4 and a positive 9/4. X is going to equal a 4, and then this is going to be 2 and a 4th. So let's talk about extraneous. If I tried to put in a 4 right here, let's see what we would get. So the original equation for the square root of 4 would equal 2 times 4 minus 6. Let's go ahead and perform that math. So over here on this side, I'm checking for extraneous solutions. So 2 is going to equal 8 minus 6. This is a true number sentence, so I know that that is going to be a solution. Let's go ahead and take a look at the 9/4. For the 9/4, I am just going to use this improper fraction right here to check my work. For me, improper fractions are a lot easier than mixed numbers. So back to the original equation. It is going to be the square root of 9 over 4. That's going to equal 2 times 9 over 4 minus 6. 9 over 4 is a perfect square, so the square root of 9 over 4 is 3/2. And then this is going to be 18 over 4 minus 6. Ooh, I am in the way, aren't I? Let me move that. All right, so 3 over 2 equals, this simplifies to 9/2 minus 12/2. Notice I converted that to a like denominator. If you notice, if I tried to combine this, I would get a negative answer. And remember, you cannot have a negative real number underneath the square root symbol. So this equation, or I'm sorry, our last answer of 9/4, that is extraneous, because it gave us a negative answer underneath the square root symbol. Let's go ahead and take a look at the next equation. Okay, so isolate the radical. The radical is not isolated. It has a minus 1 right there, so I'm going to move that over. So we are going to have 5 minus x equals x plus 1. Let's go ahead and clear the radical. It's a square root, so we're going to raise it to the second power. So it's going to be 5 minus x equals, and I'm going to go ahead and FOIL that perfect square trinomial out. So x squared minus, or I'm sorry, that's a plus 2x plus 1. Again, you have yourself a quadratic, so go ahead and set it equal to 0 and let's solve. So 0 plus x minus 5 minus 5. So I'm just going to double check my work. Minus 5 is a negative 4. Plus x is a 3x, and I just brought down the x squared. We're good. Let's go ahead and see if this is factorable, and it is. So 0 is going to equal x plus 4 times x minus 1. And let's see what happens when we plug this in. So x is going to equal a negative 4 and a positive 1. Let's go ahead and check for extraneous. A good rule of thumb is anytime you have a quadratic, check for extraneous solutions. So we are going to have the square root of 5 minus a negative 4 minus 1, and that should give us a negative 4. So if you notice, we are going to have our order of operations. Y'all, that's a 9. 9 minus 1, I'm sorry, the square root of 9 minus 1 should equal a negative 4. 3 minus 1 does not equal a negative 4. So we know that's extraneous. Let's check the other solution. So we are going to have the square root of 5 minus a 1 minus 1, and that should equal a positive 1. So again, I'm plugging in these back into the original equation. So 5 minus 1, that's going to be the square root of 4 minus 1 should equal 1. Square root of 4 is 2. 2 minus 1 equals 1. It equals, all works out. So I know that the negative 4 is extraneous because it gives us a false number sentence. So the only answer is going to be x equals 1. And that's it. That's how to check for extraneous for solving radical equations.